Hey, all you geometry fanatics. Today we're going to be looking at section 4, which is additional angle measures and segment length. So we're going to be looking at other types of intersecting lines and circles and how their angles um, correspond with their arcs that they intersect. So we're going to be looking first at finding measures of angles formed by chords, secants, and tangents. We know what chords and tangents are. Secants is a new one. So a secant is a line that intersects a chord at 2 points. A chord is a part of a secant. So a chord would, stop at the edge of the circle. The secant is just continuing that line past the circle. Okay, so um, if your two lines intersect inside of your circle, so if you have two lines that intersect inside of your circle, the measure of the angle of the intersection is going to be 1/2 the addition of the two arcs. If the lines intersect outside of the circle, notice all of these are different ways that the lines intersect outside of the circle. The measure of the angle is going to be half the subtraction of the two arcs. So if it's inside, you add the two arcs, divide by 2. If the lines intersect outside of the circle, you subtract the two arcs and divide by 2. That's the quickest way to do these. Okay, so these two lines intersect inside of the circle. So to find that angle, I'm going to add my two arcs and divide by 2. So that means x is going to equal 65. Here, my two lines intersect outside of my circle. Now they tell me the angle this time, so I'm looking for a missing arc. So that makes it a little bit different. So my angle, the formula is my angle equals 1/2 the subtraction of my two arcs. It's my big arc minus my small arc. So it's going to be 95 minus z. Okay, I don't like to deal with fractions. I don't want to deal with decimals and 1/2 z's. So the first thing I would do here is multiply the whole equation by 2 to get rid of the fraction. So that would give me 40 equals 95 minus z. That's a lot easier to solve. Subtract 95 and you've got negative 55 equals negative z. So of course z is 55. Simple enough, right? Okay, same scenario here. We have lines intersecting outside of the circle, but we do have the angle this time, so we're just going to plug it into the formula. So it's going to be the angle equals 1/2 the subtraction of the two arcs. Big arc minus the small arc. Sorry, you couldn't see that. Again, I'm going to multiply the whole equation by 2 because I don't want to deal with any fractions. That's going to give me 140 equals W minus 110. Add 110, looks like W is 250. And that makes obvious sense. Look at this scenario. We have a piece of an arc as 110, and then we have the whole other rest of the circle. Should be 250 because what do all of the arcs have to add up to? 360. Okay, so some more non-central angle type things. Let's look. Oh, this time we are finding the angle, so I can just use the formula. 1/2, they intersect outside of the circle, so it's the subtraction of the two arcs. 110 minus 30, so that's half of 80. Half of 80 is, of course, 40 degrees. Y is 40. Here, one more where they intersect inside of the circle. This time they do give us the angle, so we'll just plug it into the formula. It's the angle equals 1/2 the addition of the two arcs, x plus 30. Again, let's get rid of those fractions by multiplying by the common denominator of 2. So that gives me 70 equals x plus 30, which means that x is, of course, 40. Pretty simple stuff, right? All right, here is a scenario. A satellite in geostationary orbit above Earth's equator has a viewing angle of Earth formed by the two tangents to the equator. The viewing angle is about 17.5 degrees of the Earth. What is the measure of the arc of the Earth that is in view from the satellite? So, does that make sense to you, this scenario? We have a satellite. It can't see all of Earth at once because it's, you can't see the backside of Earth. So, it wants to know how much of the Earth, what what percentage or what arc of the Earth can the satellite see. So how do we do that? We don't have either of these arcs. Any ideas out there? This one's pretty tough to think about. So if you don't have either arc, you're going to call one of the arcs X. And then what would that make the other one? If this were 160, what would this be? That would be 200, right? If this were 50, what would this be? 310. How do you do that? So that makes the other arc 360 minus X, right? That's how we figure that out. We take the other arc and subtract it from 360. So these are my two arcs. Now I'm just going to use my formula. It is my angle equals 1/2 of my big arc, which is 360 minus X, minus my small arc, which again is another X. I don't like to deal with fractions, so I would multiply this whole equation by 2 to get rid of those. If we do that, 17.5 times 2 is 35. And that gives me 360 minus, if I put those two X's together, 2X. Okay, we're almost there. Subtract 360, we'd have negative 325 equals negative 2X. I do believe that's right. Yeah. And then divide by negative 2, and X would equal a positive 162.5 degrees. So you can see 162.5 degrees of the 360 if possible. Pretty neat. There's some nice astronomy for you, right? Or something, astrophysics. I don't know what it is. Okay. Objective 2, find segment lengths associated with circles. Okay, so we did angles on the front. On the back, we're doing mostly segment lengths. Okay, for a circle and a point not on the circle, the product of the lengths of the two segments from the point to the circle is constant along any line through the point and circle. What in the world did that just say? I don't know. But let's talk through these scenarios. That'll make more sense. Okay, so if we have two lines that intersect inside of a circle, this will always be true. From the intersection, piece times piece equals the other two pieces multiplied together. Okay, if they intersect outside of the circle, you do the outside piece times the sum of the two pieces is equal to the outside piece times the sum of the two pieces. And then this one is pretty much the same. It's with the tangent. So it'd say the outside piece times the sum of the two pieces is equal to the outside piece times itself, because that's the sum of the two pieces. Okay, so these are just some more formulas just to apply. Okay, so you look at your scenario, and we have an intersection outside, so it's going to be the outside piece times the sum is equal to the outside piece times the sum. And then we just have to solve that, and it says round to the nearest tenth when applicable. 6 times 14 is 84. 7 times 7 is 49. 7 times y is 7y. Subtract 49 from 84, and you're going to get 35. So 7y equals 35. Divide by 7. Looks like y is going to be 5 on that one. On number 2, again, intersection outside. We do have a tangent this time. It's not much different. It's going to be the outside piece. I like to do this one, or I guess I should do the other one first. The outside piece squared, so z squared equals the other one. So it's the tangent squared is equal to the outside piece times the sum. So the outside piece is 8 times the sum. 8 plus 6 is 24. What is 8 times 24? I don't know. Let me type it in real quick. Actually, I do. But 192. Z squared equals 192. So to get z by itself, we'd pull out our handy dandy calculators, and we'd find the square root of 192, right? Square root of 192. 13.9 when rounded to the nearest tenth. So z is about 13.9. Down here, number 3, just like number 1, outside piece times the sum, which would be 34, equals the outside piece times the sum, x plus 16. Do the multiplication. 14 times 34 is 476. And that would be 16x plus 256. Subtract 256, and you got 220 equals 16x. Divide by 16, and rounded to the nearest tenth, looks like it's going to be 13.8. Although I hate rounding that because it's actually 13.75. But it does say round to the nearest tenth, so 13.8. Okay, and then when we have lines intersecting inside once again, or actually we haven't seen an example like this, so you do piece times piece, so 6.5 times m equals piece times piece. Actually, I don't know if I did that right. Is that 3 is kind of tricky. I think the 3, I don't know. I'm just going to say the 3 goes with the 7. So 6.5 m equals 21. Divide 21 by 6.5. And round that to the nearest tenth, 3.2. I'm not sure. That's a badly drawn picture. But anyway, but you get the gist of it. You understand how to do it. So that's what's important. All right. So not too bad. Just try and remember those formulas. If you can't remember them, just check them out on your notes till you get them down. All right. Y'all have a great day. We'll talk to you soon. Oh no, did I not record? No.